Hello guys, today I'm sharing a network topology that I created that it will basically imitate a core collapse network, or also called a two-tier network, which is distribution layer and each different access layers, right? This one and this one right here. And so the focus on for this topology and this lab itself is to focus on layer two technologies. There's gonna be a little bit of routing because of course, you know, it will be a good demonstration for the distribution layer switching, between different subnets, right? And mainly I would like to focus on, layer two topics such as VLANs, trunks, ether channel, spanning tree, specifically multiple spanning tree, and also taking advantage of, having this dual this distribution layer redundancy to also test HSRP, right? That is basically a fierce hop redundancy protocol, Cisco proprietary, that it will help us to, have redundant default gateways. HA. We'll be also leaving a Google Drive link where you can get this topology in a YAML file, right? If you didn't know, but in CML you can upload network topologies made from other users when they are presented as a YAML file. So I can export this file and just share it to you so you can import it on your Cisco Modeling Lab software. And not only that, well, I'm planning to do this for the next Cisco Modeling Lab topology. So if you're interested on the topologies that I'm making, stay tuned. So for end device connectivity and testing, we'll be playing only with two VLANs, which is of course the ones that we are highlighting right here. But we'll be creating a total of 40 VLANs just for us to test the multiple spanning tree technology. So the decision that I took to implement the first objective on this network, it will be to basically segment this VLANs based on the access layer, right? So I decided to have a VLAN 1 to 20, but well, in reality 2 to 20, and on this side, and 21 to 40 on this side, right? So for end-host and testing connectivity, I decided to only use VLAN 2 and VLAN 21. So these two devices will be part, the only ones that will be part of VLAN 2 in a realistic perspective, of course, and this on this side, on this access layer part, and this basically this device from this host name called Jeff being part of VLAN 21. So we can just go to the access switch 2 and we can verify. And you can see right here that we have assigned these two switch ports to VLAN 2. And we can also go to the access switch 3 and we can do the same. And we can see VLAN 21, it will be Ethernet 1 and Ethernet 0, the ones assigned for VLAN 21. Now, for trunk connectivity, and basically let's go to one of the distribution switches and we can see the what we spoke about segmenting VLANs, right? Having VLAN 1 to 20 on this side and 21 to 40 on this side. So let's go to show interfaces trunk, right? And we can see right here that, of course, without touching spanning tree yet, that of course it might or it might not block one of the ports. And we can see right here that we have the VLANs allowed on each trunk, depending on the access switch and the access layer that is connected to, right? So we can see right here that gigabit 2 and gigabit 3 are have the VLAN 2 to 20 allowed into them, and the other side in the port channel 10 and the gigabit 0 we have the other VLANs that are assigning the other part of the access layer, right? 2140 and 2140. And of course, the same goes for the distribution switch too. Also, in the side of this access switch, I decided to implement Ether channel. Not really about the reason of having servers. I just add this added as a, you can say, decoration, right? But basically I added just to, show the concept of ether channels on this lab. I think will be helpful for whoever is learning it, right? So here we can verify that we actually have them already done. If you want, you can reload, you can, wipe the switch down and do the entire configuration from zero. But usually when you download the YAML file, everything should be configured. If you want to, of course, check the exact configuration that I'm checking right now. But we can see right here the two switch ports that are basically bundled into each port channel 10 and port channel 20, as we have right here. Okay, so now let's see how the spanning tree protocol topology and features, have been implemented on this lab, right? So first, let's start with the most basic part that I consider is the most basic part, right? Is basically setting the end, the edge ports for the spanning tree topology and port fast, so it doesn't, it can just skip the timers, and whenever the device, from down goes up again, it can, get connectivity as fast as possible to the end devices. And also BPU ward to make sure that if someone, disconnect this server right here and connects another switch, whenever the new switch sends a BPDU, it blocks the port, right? So we can see right here, and so raw interface. Let's put Ethernet. Let's put 1 0, but it will be really same for the other one. It's once one. But you can see right here how we enable perfast and BPD ward, as we were saying. And the other feature that we want to look at is root ward, right? So each of these, I configure them to be the root switch for each MSTP instance, right? So what we want with the root ward is that if if one of the switches, depending of which instance, receive a root, no, a BPDU message that has a lower priority ID, basically blocks the interface. We want to keep MSTP topology as it is right now. So let's just go find the configuration, the root configuration. Actually, it can be on, it will be in, I don't remember what port I did it, but let's, recap it really quick. And for example, on Gigabit Internet interface 2, so this one right here, so we talked that on this side there will be the multiple spanning tree instance 1, which will be the VLAN 1 to 20 on this side. So yeah, so we enabled root word on this interface. So in order that if this switch decides to be a root switch um, for any of these VLANs, you basically shut down the port, right, until we fix it and restart the port. Basically, shut down, not shut down. And we mainly want to keep this switch being the root bridge for these VLANs, right? And the same thing, the same goes for the distribution switch too, right? For these VLANs right here. Actually, I think I even skipped mentioning it. I skipped showing the spanning tree, the multiple spanning tree VLAN mapping per instance. I forgot to show that. So show spanning tree MST. Let's show that really quick. What you can see on this scenario, we have right here, mm, that it is the root bridge for uh, instance 2, the multiple spanning tree instance 2, which will be the ones from this side, the VLAN 21 to 40, and of course it won't be for the VLANs that are on this side. So let's just check the MSTP configuration commands to verify the information that we just saw right here. And it basically, this configuration is similarly for these two switches, except that of course this distribution switch is trying to be the root bridge for this segment, for this part for this connection to this access layer. And for this distribution switch, it will be the same, but for these access layers and these VLANs present on this access layer, basically. So on this distribution switch too, we can see right here the mappings. Of course, this is a single region. We made this as a single region, so this distribution switch will be in the same region as this one, regardless. So what we did right here, we do this. We of course we did the same mapping as this one, but what we did on this case is we lower the priority for the second instance to make the switch in the root bridge for this segment of the network, basically as we explained. And this is the configuration for this distribution switch one. You can see that it's similar. It's just that we of course lower the priority for depending of the instance that we want to make the switch a root of, right? You can see for this one is instance one and this one is instance two. We can also see how in each access switch we have the same VLAN mapping and the same MST name, right? Region name, I mean. So to make sure they are gonna be in the same region, right? Finally, we can also verify how the hot standby routing protocol is configured in the topology, right? So of course, depending on what we configure as the root bridge for each VLAN, we set that particular VLAN that the switch is a root bridge, a the active router on each particular VLAN, right? Well, on this case, only VLAN 2 and VLAN 21, since these are the only ones that we will choose test for end-host connectivity for simplicity, basically. We don't want just to make this network huge unnecessarily, and yeah, basically. So you can see right here that we have the SPI for the VLAN 2. We set it as the active router by making the priority higher as the default one. That will be 100. We set it up at 110, and we also configure preemption for the SPI. So whenever this device goes down and the SPI2 for this switch takes over, and then the distribution switch one, the original active router will come back. It will take its place again, right? It will become the active again instead of this one remaining the active, right? And we can see right here that just to verification and refreshing, we can see that the VLAN 2 is the one for the mapping that we set as the root bridge, right? So VLAN 2 is within this one, so within this bridge priority. So the root bridge will be in this one, which will be part of the VLAN 2, right? So VLAN 2 will be part of it, vice versa, right? So you can see the same, thing, but in a reverse order for the distribution switch 2. The VLAN 21 will be the active router on this case for this VLANs on this part of the network. And we can see also the priority is set higher, the preemption is also set, and yeah. Okay, so now let's test that the HSRP configuration is indeed what we wanted, what we meant to do, right? So let's use a show standby brief to see which one, to make sure that, as we said, that the VLAN 2, this distribution switch is an SPI for VLAN 2 that will be on this switch. It will be the active. We can confirm it is indeed the active, and the standby for the other one for the VLAN 21, which will be on this side, the one that he's not the root switch, right? So let's do the same on distribution switch 2, right? Which will be the contrary thing that we just said. You can see right here that it should be the root, which the active router for VLAN 21. This is standby. So standby with, and we can see the opposite thing as we saw on this distribution switch, right? It is the active for VLAN 21, and yeah. So now let's actually test the connectivity, right, between subnets. Make sure that they can actually reach out each other. We can actually show the IP route, the routing table, make sure that it can actually reach. It has the route for both subnets, so it knows the route for subnet one, well, VLAN two, and subnet for VLAN 21. Hence, we should be able to reach and not make inter-VLAN routing because, as we were speaking, this one will be the active router, active default gateway for one of the VLANs, and this will be the active gateway for another of the VLANs of this topology. It wouldn't be an inter-VLAN routing, since inter-VLAN routings, it wouldn't go out of the routing wouldn't go out of the router. It wouldn't look of it outside of the router. It would be just resolve it by itself. This may will be probably happening if we will have configured more VLANs. Maybe we add two more VLANs like VLAN 3 and VLAN 22. Let's say that VLAN 2 and 3 share the active state on the HSRP topology for this router. In this case, if VLAN 2 want to speak to VLAN 3, they won't need to inter-VLAN routing. The same thing for VLAN 21 and VLAN 22 for this switch right here, right? But in this case, since we are using only two VLANs, it won't be. They will just basically be routed from this default gateway to this default gateway if we want to, speak with different VLANs and route between these two different VLANs. So let's go to one of these hosts, like this one. These are Ubuntu-based hosts, right? I like Ubuntu. I think it's one of the easiest ones to configure network-wise with the NightPlan file and stuff. And so I'm gonna be using it. So let's actually try to reach out this one, right? This host right here, which will be the 4 in VLAN 2, right? And you can see right here that is reachable. Of course, of course the other one as well. And here, of course, we can verify the host, the IP for the host that I configure for the interface. And also this wasn't supposed to be a Linux network focused video, but we want to, of course, highlight that, of course, we set the default gateway as the one that is active on the current HSRP domain, right? And to wrap up with the video, let's actually test uh, how the HSRP redundancy works in our in our network basically. So let's actually keep in the other network, right? The other subnet, and it should remain right here. And in the other side, meanwhile, I believe this one is the router for VLAN 21. So what will we do? We can either reload it or shut it down. Let's actually shut it down to have kind of like to not have like running against the time for when it comes back online, so we can just check the change in piece and everything without rushing. Let's just stop it, right? Everything should go down right here. The distribution switch 1 should detect it, and it should go up. And let's just should the timer should hit soon. I believe it's 10 seconds if I'm not wrong. But let's check that if it is the active, right, on the other one. Okay, so now I hit the timer, and now it should be active for both, right? So we can see, the how it went, how basically the gateway access for VLAN 21 was down for just few seconds, and it went back up after the distribution switch took over from standby to active for VLAN 21, and basically that. And now let's have it back on. Hopefully I saved the configurations. I believe I did so on the distribution switch too. But yeah, I always do so, so I'm pretty sure I didn't. Let's Okay, when it goes down, it will remember the reason why I'm showing, the distribution switch 2 coming back on is because remember we configured preemption in this lab for HSRP. So the distribution switch 2 should take over after coming back of course, not instantly. It's gonna boot up some services and stuff and processes that it needs to. So meanwhile, it's gonna be still active. This distribution 61 is still active on both. Just give it some time for it to come back. Switch right here completely, and it really shouldn't take. It shouldn't take a a downtime. It shouldn't take a peak like it did on this side when it's taking frames, and it should like remain stable as it is right now. And just wait for it to come back. Okay, it's coming back. And it should, whenever it does so, it should, yep, saying now that it's going to stand by, such as speak. Yeah, it's negotiating. It's negotiating with the other switch, and now we can see it's on a standby. And you can see right here that actually I say the wrong word, not the peak. Basically, a drop on the bit rate, right? On this side, well, actually, we did see a little bit, but it's just when it was, pre-negotiating who is the active router, right? So we can see right here that it went back to normal. This took over as the switch took over as the active again on VLAN 21. Right? It's actually check and confirm, even though we already confirmed it on the other side, on the other switch, right? But let's just have it for just display, right? So yeah, so you can see it's back. It's back in active state on VLAN 21, and yeah, and this should be all the topics to show in this topology. And remember that I'm gonna leave the YAML file in the Google Drive directory, which I will make public so you can grab them, and not only this one, but maybe a future lab that will be uploading, so you can just be free and just look at the topics that you're interested on and just download and play yourself in your own software. And nothing else. I think that's it. Thank you so much. Bye.